Alright, then we start. So, remember when we started with this, we were talking about how do I how would my learning algorithms behave when I have text, right? There was a very good thing with image. What was that? No input was to be prepared or no representation of input was to be prepared. Your digital image is a good input in itself. Okay, that is a vector, that not a vector, that is a tensor, right? You have a 3D matrix already and you did not have to do anything. In this case, when we are saying the movie was bad, then we have absolutely no idea how to represent the movie, the movie was and bad. Okay. After taking this detour of word representations, we now know that how to represent them. So, how would you represent them now? If you were supposed to compute the sentiment of it, how will you do? If you were to compute the sentiment of this, how will you do? Something as basic as that you can think of. So, something even as basic as this works. Take word embedding of the, or you can even simplify this, remove all these stop words, okay, movie, or take whatever, okay. So, the movie was bad, just take the representations of all of them, just take word to vec embeddings of all of them, add and finally add a classifier, right, softmax with 5 classes and you are done. So, earlier you were doing this based on words. What will happen? And have you done this sentiment classification in machine learning or somewhere there? Using just normal linear regression, sorry, logistic regression? What you do there was, so you have this data set of all these comments or reviews, then there some human labeler will label them positive or negative, and then you will try to see which words fall into negative side, which words fall into positive side, do a statistical analysis of that, and then finally when you have a test review to decide whether it has positive or negative sentiment, right. So, you were taking word as an atomic thing there and you hardly had to do anything semantics about that. I mean, okay, yes, there was semantics associated because good will go to positives, bad will go to negatives, right, and then there might be things like not good, not bad. So, there those algorithms will struggle. In this case, word to vec gives you awesome representations, very nice representations. So, how will I solve this problem of Taj is in Agra? So, no, this was NER. So let us just talk about sentiment classification right now. So, if this is the question, the movie is wonderful, how will you do sentiment classification of it given that you have representations now? Can you make that network for me now? As simple as you can. So, I am not asking you to be fancy, right? The simplest thing that you can think of. So, what is the statement? Let us say, even though I have never heard the movie was bad, people will either say the movie was pathetic or it was not bad, okay, but ठीक है. Okay, so the movie was bad. Your goal is, so we are just doing two classes. Either we'll say it is bad or we'll say it is good. So either it is a positive sentiment or negative sentiment. It is just for simplicity, because you know this does not change anything. If there were 5 classes, instead of sigmoid we will use softmax, and there is no other difference. Okay. So tell me, how will you make a network for this? You are supposed to do sentiment classification, positives and negatives, that's it. Easy, super easy. So let's say you have used word, so somebody has given you now word2vec. So what is the final output of running word2vec? It is your embedding matrix E. Okay. Embedding matrix, how does it look like? I am assuming each word vector is 300 dimensional. So how many rows? 300 cross mod V. Why mod V? So I have, this is my vocabulary size, and every word, so this one is my word vector. All these columns are my word vector for these. So how will I get word embedding of the from this? Assume mod V equal to, so let's fix everything. Assume mod V equal to 10K. Exactly. So word embedding of the will be E dot 1 hot of the. Let's say the appears at 8943. So what is the size of E? E is 300 cross mod V, which is 10K, and this guy is mod V cross 1. So that gives me 300 cross 1. This gives me the embedding of the. How will I get embedding of movie? E dot O 6896. Okay, assuming movie is there, and then this would be, let's say this is something like, and so on. E dot O will come after that, so 9582. Bad, let's say E dot O, I don't know, 1587. Okay. So you have all these embeddings now. You have 300 dimensional vectors for every word. Now can you tell me, how do I make a network that does this binary classification? This is super easy. You should be able to come up with this. See, until now we were struggling, how do I give this as input? Now we know how to give this as input. So once you know, come up with something, and trust me, it will be the right thing to do. Whatever comes to your mind is a correct answer. Don't think you don't know RNNs until now. You can do it without RNNs. Okay, close. What will be problem with this if I make this network? So 300 dimensions of the, 300 dimensions of movie, and similarly for next, and similarly for next. What's wrong with this? If I make this network? No, what's wrong with this network? It's a logistic regression network. What's wrong with this? कैसे? Exactly, right? Here your input was the movie was bad. You will need 1200 neurons in the input layer. The moment the movie was not bad, it becomes 1500 neurons. Whatever we have learnt until now, we know that input neurons are fixed, output neurons are fixed. You can do whatever with the hidden layers, but the input and output are fixed. So this is violating that rule of ours right now. So how do I improve on this? But this was close. What comes? So, see, once people were done with word vectors, okay, there was a flood of sentence vectors, document vectors. So, how would you compute sentence vectors in the most trivial way? You have these embeddings, add them all. So, you add them all, it does not matter how many words are there in my text. If you add them all, that resultant vector will also be a 300 cross 1 vector. So, this way you fix it. So, what you do is you have a 300 neuron input and then you have 1 because you just want 0 or 1. So, this is the simplest network that if you do not use word to vec. So, here if you see, the only difference is now you are using word embeddings and suddenly your algorithms start outputting a very good performance. Okay. So, until now you were doing things without word embeddings, performance was pathetic because absolutely there was no relationship between the words captured. Once you started, so where is this E coming from? Where is this E coming from? E is coming as the output of word to vec. So, actually Google has done this for you. Google has uploaded all these weights. So, anybody can go and download this E. Go and download this E, use it in your own network. Okay. Similarly, Stanford guys, they had uploaded word vectors of glove. So, whichever you like, you want word to vec, you want glove, whatever you want, go and download those embedding matrices and wherever you see, wherever you see words, just multiply the one hot vector of embedding matrix with that particular one hot vector. Is this thing fine? This is easy thing that we have done until now. Nothing special. Okay. Chalo. So, you now know how to do sentiment classification. This was an easy problem. Now, next thing that I want you to help me with is named entity recognition. So, in this case we had Taj is in UP. Now, how do I prepare the training data set for this? This is just one example. You will have so many, you will have so many sentences. So, here in this case Taj is 1 or 0? 1, 0, 0, 1. Right? We are doing NER, that means these are named entities and then you can define named entities according to your problem. So, for example, if you are doing analysis of contracts, then maybe dates are important for you, right? Parties are important for you and so on, okay. So this is fine. How do I solve this problem now? Now I know, so this is where we started sequence to sequence with, right? Until then I did not know how to represent these things as numbers. Now we know how to represent these things as numbers. Simply download embeddings of word2vec or glob and start using for these, okay. Now 1 0 0 1, these are my output, this is my input. Yes. How do I prepare my data set now? This is a question for you. Yes. How do I prepare my training data set? I just told you that doing it for sentiment analysis was easy, okay. How easy or difficult is it in this case? Embedding. So see, whenever you will deal with text, the very first operation you will do is multiply the one hot vectors of all these guys with embedding matrix, okay. In the days of LLMs you don't do this anymore, but for us we are still doing it, okay. Yes. So what do? I have the embedding matrix. So I have the embedding of Taj now. So let me just not write numbers, I will just write words themselves. I have the embeddings of these now. O was one hot vector, E is their embedding. What is the size of each E? 300 cross 1, right? So how do I go about solving this? कोई तो आइडिया दो यार, अच्छा बुरा जैसा भी. I want to make a network that solves this problem. Does this look like a binary classification problem? For every word, मतलब this is something, it should have come from you. For every word, our answer is either 1 or 0. So let me just try to do this. So Taj is in UP and I have, let's say, a huge amount of text that I want to run NER on, but for right now my thing that I am running it on is Taj is in UP. So how will I make this network? What will be the input? 300 cross 1. What will be the output? 0 1. So it's a binary classification thing. Everybody connected to everybody. And what's wrong with this? So output is 0 1 because for every word I will either say 0 or 1, either it is a named entity or it is not. So when I input Taj, so when I input embeddings of Taj, right, I will say either 0 or 1. What's good, bad, wrong with this? Exactly, you are supposed to do everything together, right? What advantage we had in case of sentiment classification? You had embeddings of words, you added them and you call that as a sentence embedding, document embedding, review embedding and so on, right. In this case every word is still, if you are going to do it this way, you are doing it for every isolated word, okay. This, even though you can go and try, but is not the most intuitive way to do this. So there is nothing that stops you from doing this in deep learning. If you say this is what I am going to do, go ahead and do this, nobody can say you are wrong, okay. But this is not the best way. So if you write this in exam, no marks. Even though I would say this is fine, not wrong, but no marks, okay. So this is not the right way. This is where now RNNs come in, okay. What we do is take this network, rotate it 90 degrees. So what we are doing here now is so how many neurons? 300. Now what is my output? 0, 1, okay. And of course it's a logistic regression unit to start with. This is what I have. And what is my input? Input is ETAJ. What is ETAJ? Everybody sitting here should know what is ETAJ. What is ETAJ? It is a 300 dimensional vector. It is a 300 dimensional vector, right, that you are going to give input, okay. Now what? What do I do now? So I'll change this network a bit now. What I'll do is I'll put a hidden layer here. Okay, and assume that this is 100 and finally this is 1. This is good old neural network that we have been doing for last 3 or 3.5 months. Tell me the total number of parameters in this network right now. I mean, you don't have to add them, you just have to give me the weight matrices. So this one is 100 cross 300, bias is 100 cross 1, this is 1 cross 100 plus 1, okay. So this is the total number of parameters in this case. But you did this for ETAJ, okay. I am doing that same thing that I did there, just that I have added. Now this is yet another same thing, 300 300 100 1. I am not drawing this anymore, I will need this space for something else. So I am removing this, but you can see at this layer everybody will have 300 neurons, at this layer everybody will have 100 and at this layer everybody will be 0, 1, so just 1. So I will just quickly draw this. These are not 4, they are 100, okay. So let me put dots in between. Okay. At this layer everybody has 300 neurons, 100, 1. Now this was, if this was ETAJ, what will this be? E is E in EUP, and for the time being we are assuming UP is actually a word in my vocabulary, that means Uttar Pradesh, a state in India. Okay. So this is what it is. What is wrong with this network? I mean, all I am doing right now, this is just one network. See, this is just one network. First I input embedding of Taj. I train it to say either 0 or 1. Then I input E is. See, how many examples are there if I talk about this as a binary classification problem? How many examples are sitting here? 4 examples are sitting here, right? First example, second example, third example, fourth example. How many of you are not with me in this case? Everybody is okay with me? How many examples do we have here? 4. If I am seeing this as a binary classification problem, there are 4 inputs, there are 4 outputs, so there are 4 examples. And we said this is not intuitive for us. So what will happen? We are saying, if I were to use this network, this is how it will look like. How many of you have issues with these 4 networks that I have drawn here? They are the same network. They are exactly the same network. I have drawn them 4 times. Okay. This was passing of first example, passing of second example, passing of third example, passing of fourth example. Otherwise, I could have said one after the other, keep on passing examples like we did in all the everything. So how we were training this network until now? If I have 10,000 examples, all 10,000 examples will pass through this network. Okay. Similarly, any questions with these 4 networks here? Okay. What now we are coming to RNNs. So next 5 minutes, pay attention. This is my normal deep neural network. What we do in RNNs is, and that gives you an RNN. So what is happening here? This hidden layer. See, if you keep this isolated, there is no feedback. Now this hidden layer will be passed to next hidden layer. This hidden layer will be passed to this hidden layer, and this hidden layer will be passed to this hidden layer. You cannot convert this to normal DNNs because DNNs were feed forward. Now you see the name. What was the name until we have seen until now? They were feed forward neural networks. What does it mean? So layer 1 will feed to layer 2, layer 2 will feed to layer 3 and so on. Feed forward. They are recurrent neural networks. That means you have loops here. Okay. So if I were to make this particular, instead of 4, why I don't want to make 4 and why I just want to make 1? Because they are not 4 really, they are just 1. So how can I make this as 1? So I am just doing this. This is 300, this is 100, this is 1, and this guy loops back. So this is yet another representation of neural networks, I mean RNNs, the rightmost one. With just one network, you have a loop on hidden layers. As many questions as you want to ask, please ask them here. So that's a good one. Taj is, so this was input Taj is in UP. No, this is not 1. So now you will have a separate output for Taj for is in UP. See, what this is doing is, you had a lot of motis, and this basically the thread that keeps them together. Right. So now how will I feed the input here? I give the embedding of Taj. Let's say output comes out to be 1. Okay, whatever the output is, so this becomes my y hat. So I'll call this, so it's a good time to introduce this notation as well. So this is my y hat, this is my y hat, y hat 1, right? This is my y hat 1. Why triangular brackets? So this will be y hat 2, this will be y hat 3, and this will be y hat 4. I think I'll get rid of this guy now. Yes. Why triangular brackets? And see, Taj is in UP. Is this just one sentence? So technically it is one example. So one, actually I have done it the other way around. So let me, you will have triangle, so I should have left space. This is first example, first word, okay. First example, second sequence word, so second timestamp basically. First example, third. First example, fourth. So what is this notation? See, what we were doing for, what we were denoting parenthesis with? Example, right? Remember we wrote something like yi minus y hat I. We wrote this in parenthesis. Why parenthesis? Because we are saying it is the ith example, okay. So this was the ith example. So this is my first example, but my first example itself has so many words in the sequence. So that sequence is denoted by these triangular brackets. Is this notation fine? See, let's say my next example is Harry Potter and Hermione Granger invented a new spell. Total words are 9. So, and where will I have output as 1? Harry, Potter, both will have 1, and 1 or 0? 0. Hermione, 1. Granger, 1. Invented a new spell, 0 for all of them. This example has how many timestamps? How many words? 9. Okay. So in that case it will go from, let's say it is second example. How will we denote this? y2 1 all the way to y2 9. Okay. We denote tx. So I think I'll come to that later. So let's first talk about just this one. More questions here. I am not done with questions yet. You should ask more questions. This is just one representation of all of them. First of all, so this particular weights here, okay, I am calling, we call them W. It takes input of the kind X and gives me output of the kind A. So this is WAX, this is WYA, and this is WAA. So these are these three matrices here, WAX, WYA, WAA. Okay. Tell me what will be these matrices, same or different? How many of you go for same? How many of you go for different? So how many of you go for different? See, raise like this, I mean. How many of you go for same? Dono? So, and you have two reasons. Why different? So this should be Y1, 1, 1, 1, and similarly I will have WAX 2, WYA 2 and WAA 2 and so on. Is that right? Is that right? And what's wrong with this? WAX will be same? Why same? Okay, so one is, he says ki you will have a lot of parameters, but in deep learning who cares about the number of parameters? If there are a lot of parameters, let them be. So even though this is a concern, right now we will not take it. Anything else? Yes. See, we said every machine learning, right? What it does is it tries to map this input to output. Okay? They may be very sophisticated functions, right? So F is our neural network. Now input is your Taj is in UP, and now that is transformed to their word embedding. So inputs are actually a vectors, 300 dimensional vectors. Outputs are 0 ones in this case. Okay. This function, what do you want this function to learn for you? At every timestamp, see these guys are timestamps. Okay, 1, 2, 3, 4, they are timestamps. So let me just make it clear. This is first timestamp, this is second timestamp, third and fourth. If this were a video, what will be timestamps? First frame, second frame, third frame and so on. If this were a audio waveform, whatever output you have in any case, okay, and so on there. Right, now coming back to this. So I'll get rid of this. What function do you want to learn? That will help you answer what should be there. You want to learn a function that gives you 0 or 1 for every word. If your parameters were different, see I said this network is just this network, we have just rolled it in time, else it is the same network. Remember, I had just drawn this. If I input E Taj, get 0 1, forget this guy. If I input E is, get 0 1. If I input E in, get 0 1. If I input E UP, get 0 1. If I don't have this, parameters will be same or different? Because it is that same neural network. See, this is where a lot of people are confused. So I want to take this very slowly. Parameters same or different? एक बात बताओ. You are doing housing price prediction. You have 10,000 examples, right? Will you change your parameters for every example? No. Your number of parameters are not dependent on training examples. They are a function of which network, I mean, they depend on what you want the network to be there. Once you fix the network, what will happen? all the training examples will be passed through that network and you will run gradient descent, right? This is what it means. Is this fine with everyone? Same network, you will pass all the training examples. Here you have training examples. Why do you want to have different parameters here? Where the only difference between this network and the earlier network was, here you have this loop. If you remove this loop, this is same as before. So why do you think we should have different parameters for every sequence? One reason. Second, if you indeed do this, network will learn what you did not intend. So what will network learn? These parameters will be specific to second position. These parameters will be specific to third position. Your network will start learning things position wise. You don't want that to happen because position is something that is not in your control. Last thing, what is the function that you want to learn when we said y equal to fx? The function that you want to learn is, given a word, tell me whether it is 0 or 1, okay? And that function stays the same for all of them. Why should it change? Given a word at any timestamp, what do you want to do? Tell me whether it is named entity or not. So by this question does not depend on which timestamp I am on. So having said everything, it is just this network. Good old deep neural network, feed forward neural network, just that you have a feedback loop. What that feedback loop will do is this is that feedback loop. These two are equivalent representations. These two are equivalent representations of the same network. So when you were at timestamp 1, you did this computation and the output of the hidden layer were passed in the next sequence. See, if you see, this thing is happening in time. See, if you were training this with 10,000 images for image classification, will the order of images matter? You are doing image classification for 10,000 images, will the order of images matter? But if I input in is UP Taj, is that the right sequence? No. So in sequence cases, sequence matters. So Taj is in UP. This sequence actually fixes, so this neural network actually fixes that sequence. Taj will come first. Once computations of Taj are done, I will do computations for is. Once computation for left hand side is done, I will do it for this one. Once computation for everything is done, I will do it for this one. Is information arriving here from there? Is information arriving? See, this is that connecting thread, information is arriving. More questions here? Sorry? See, sequence is not a problem of your network. Sequence is a problem of your modeling. When you had an image, it was a complete thing in itself. When you have a video, it's a collection of frames. And it's a specific order of frames. You can't really, so if I have 10 images, I can randomly permute them and train. But if it's a video and I have 10 frames, I can't do that randomly, right? I can't permute them anymore. It is this sequence out of 10 factorial sequences that makes sense. Rest 10 factorial minus 1 don't make sense. Okay? So whenever you have sequence data, these networks capture. Now if I had Harry Potter and Hermione Granger invented a new spell, how will this network look like? How many units I will have? 9. So you will have 9 timestamps here. WAX, WYA, WAA, same for all of them because it is the same network. So basically this is just WAX. It takes a lot of time to digest this. If you are not getting it right now, it's okay. Just keep working on this. So this will be WAA, this will be WYA, this will be WAX, WAX, WYA, and then next to this will be WAA, but there is nobody to receive that, so we just stop there. हाँ I don't get what is randomized. Okay, see, नहीं, देखो, very first thing, your inputs are sequences and sequence should be maintained, full stop. Is that right? If you have those kind of problems, feed forward neural networks will not work. What are CNNs? CNNs we have seen are nothing but feed forward neural networks. You can convert one to the other, but you cannot convert this to DNNs. Why? Because of this feedback loop. It is inherently different from feed forward neural networks. WA is not changing. It will change when you will train. It will update as your examples come. Same thing. So let me first take attendance. We'll take a 10-minute break. You guys discuss among yourself and we start discussing this again. This takes a lot of time to sink in. Which one? The right rotated one? This is the same. I have just rotated it 90 degrees. हाँ? अब देखो LLM मेरे को नहीं आते हैं. ओके, अभी RNNs की बात करेंगे अपन. We'll talk about bidirectional RNNs, but right now we are just here trying to make sense of this thing. Okay? Yes. Good one. बाकी दोस्तों से बात करो एक बार.